So we are revisiting our Urban Farmer game again. We have 9 weeks left for the vertical slice because we are planning to attend DevGam in spring 2021. So it's in 2 months. It's 9 weeks away, I believe. Let's get going. So today's plan is to work out the sun's rotation so that it fits the time of the day. Should probably separate these two areas. It's more legible. Let's see. Yeah, we could just do this in difference. It's going behind it. Have the hot here. Word. Here is time. Let's see, this doesn't have any height. This object is I see. This has some height information. Let's look at it. So it has size 22. This guy doesn't. 0. You can actually force some minimum height or fix it. I wonder if this is gonna, because when it's 0 in the effective range, then when it's clipping, showing it. So I'll just for now force the, say this, let's give 60 to this. I'm missing something fundamental. Expand in the vertical. I'll just pull this area to the other monitor so I can actually see my slide. This guy probably be expand. So I have an arbitrary date. I was testing this code yesterday. Say time. Yes, let's say we are the first year, the last day of that year, and it's just a few minutes before midnight. When we launch the game, every second the timer goes off to increment the minute value. So then when we hit the midnight, then it's the first day of the second year. So far, so good. Now, this value, though, doesn't reflect where the sun is. So ideally, when the sun is at 90 degrees, it's right above us. It's where the shadow is the right under the objects here, trees. And as the sun's angle goes higher and higher, so it's getting darker. So when it hits 180, it's only coming from the west. So we only see this part of the trees highlight. And in the morning, when it's 0 degree, then it's the east, so it's the sunrise. So between 0, which is sunrise, 90 noon, 180 sunset. We have to map these rotation values to the time of the. As we go above 180, this is actually where I should probably make adjustments, because if you think about, well, I don't want to start a whole conversation about whether Earth is flat or not. That's just nonsense. But by simple logic, when we have a plane here, this plane, where we have objects sticking out, when the sun hits 180 degrees and it's coming from the west, so only the left, like here we only see the left sides, these trees highlighted. Anything over 180, technically it should go, the sun should go below the horizon. So we should actually start seeing less and less of the sides here highlighted. Although that seems to be happening, it's happening quite late. It should be happening more drastically. I believe that's happening because although the sun is actually 3D view here. Here's our sun. And the degree is 90 degree. Of course, this is actually, so it's noon. Because we had to reverse the values to, what you see on the interface is 90 degrees, essentially minus 90 degree in the interface here. So at sunset, this is what we are looking at. Sun is casting light only in this direction. So when we have our plane here, trees are up. Normally anything lower than minus 180, let's 225. So sun is technically going into the other hemisphere. So when we have a plane here for the horizon line, we shouldn't have any light coming through that plane. I think that's exactly what's happening. We have the level here. I think I used to have some kind of ground here. This will do. Yeah, so when the sun goes below this plane, it should not be casting light through. I'm not sure why that's happening. But for now, our problem is to map the date time to the rotation. Because if we could do that, then we can later fix the light penetrating through the plane. So read some code and make sense of it. So we have an event bus, which is handling the sun's movement. Again, this is all conventions here. Not really suggesting that the sun is moving around Earth, but from the player's perspective, sun is moving and casting shadow. So every time sun moves, or every time there's a ticker, extract here, timer, So every second we have the timer kicking off, which is adding 1 minute to the game time, which is then emitting the sun's move. And sun solar cycle is listening to those events. Every time sun moves, this is where we have to map the proper way. So yesterday I noticed that I have to come up with a solid algorithm to calculate the sunrise, real sunrise and real sunset view. Because depending on where you live and the time of the year, sunrise isn't always at 6 in the morning. Even noon is never at noon clock time. So the real noon, where the sun is at the highest angle, or the right at top, isn't always 12:00. So this calculation will have to be done later. So for now, let's assume 6, 12, 18 is the base values. So 6 should have sunrise. So this value we are getting and printing is giving us the hour and the minute. So that's this is going to be we need the minute. So the idea here is that when these two values indicate that it's 6 in the morning, then the angle should be, writing pseudocode here, if it's if it's 6 o'clock in the morning, then sun's value here, the rotation degrees should be 90, which is, when I created this solar cycle, sun in here, I created this slider here so I can see the rotation. This won't be used later. For now, we could utilize this such that rotation x this guy, not the label, rotation x's value will be, when that's 90, then it will trigger this event, will change the directional light's angle. So assuming that later we are going to need another function that will most likely return some kind of dictionary set of values, which will have these values. I should at least represent a dummy version of, because I need that to do my if check here. Does it make sense to do something like, well, I mean, we can just arbitrarily say something like this, which is very naive. If the hour is 6, the minute is 0, then it's this. But then the next question is, perhaps the hour is 6, but the minutes are increasing. And we get to the zone of like, it's 7 in the morning. So the rotation value is no longer 90, it has to be over 90 so that it, approaches 180. Sorry, this actually is 0. Sun. But the same thing goes here too. Say it's noon, it's 90 degrees, as it's going to approach 18 hours, 6 in the afternoon is going to be 100. So anything in the afternoon, this 90 will increase. And anything here starting at 6, this 0 will approach 9. So I should still write some kind of logic here that gives me an approximate rotation. What we can do for now, before we go into crazy details of how whole system works here, say between 6 in the morning and 6 in the afternoon, we have 12 hours and we have 60 minutes. So essentially we have 720 intervals. This 720 intervals is controlling 180 degrees. Similarly, for 24-hour time, for 1,440 minutes a day, we are covering 360 degrees. So the rotation value is 360 over what is the hour value? It's daytime that hour. How many hours it is during the day times 60, which is the minutes, and then we have to add the. Then we don't need this. This could just be in action. Every time a minute goes by, okay, let's try this. So 0. can't divide by 0 because when it's actually midnight, it's division by 0 mistake. You have to clamp the values too. We also have to just to be rounding numbers as well. Or rounding is not necessary. It's fine. Let's see. Okay, let's think of the extreme cases, except the midnight. When it's noon, so the hour value is 12. 12 times 60 is 7, and the minute will be 0. So 720, 360 over 720 is 1/2. Which then okay, I think I have to map the values here. Sample. It's 6 in the morning. We said the value should be 0, which actually means that for 360 minutes, still should be when it's noon. For 720 minutes, those should be and 1080 minutes. It's 00. Okay, it's making a fundamental mistake or not. No, it is actually okay. When it's 24, which is midnight, you could consider these values as like 550 turning to 600. 1,440 minutes will have passed. I think this is where I get confused. I'd like to think that this is going to be 360 degrees, but it's not. And it kind of has to be. Because every 6 hours, if you move rotation 90 degrees, which is actually correct, because 0 is essentially 360. Another 90 degrees, 270 degrees. Just 6 more hours after 6 in the morning. Everything maps out just as cyclical values. That essentially 24 is 0000. 6 more hours is here. So 90 more degrees over this 360, which is you gotta either do this with a modulo calculation or some kind. I think that's where I was here. Mind you, we still have to take. But let's assume the middle range will is 2. So when it's noon, 12 o'clock, saying 720 minutes will have passed. This will be 700. So then the value is 0.5, but it should be right now. This is giving me 12 o'clock. It's 10 o'clock. Is it 1,008? Somehow 0.3 degrees. Okay, time. Kind of gets worse. Yeah, well, it's 24 hours. There's so for every time the denominator here is we are adding 90. Feels like a no-brainer and kind of what if we actually yes, we are covering 360. We are essentially spending 1,440 minutes to cover whole rotation. Go noon, going to give us 1, 2, exactly 10 at 6 in the afternoon. No, it's not. It's 1 plus. 4. Here's the confusing part again. Why is this interval so large here? There be another pyramid such as 1 plus 2/3. Hmm. My math. No, I'm tired, but 480. Okay, this part doesn't make sense. Yeah, I was asking why this interval is so large. This interval. That's because this is another correct. We'll be doing a division by 0. So we will have to protect the case. This doesn't matter. I bet if I did the 6 o'clock, the interval between 2, what has to be here for 6 will be the exact same as 2. So for 6 in the morning, the section still seems. Sense. Time to use pen and paper. I may as well turn on the camera since I'll be writing stuff down and there's the screen. Also thinking whether that minus rotation really seem to match perfectly, except the sine one. However, you say minus 90, 270 is in the 100% sure. Let's change the sign of the values. Rotation will hit something. For now, let's just say you get 90 degrees, which is noon. 720 minutes have passed. It's 1080 minutes. Go to this route. I do slide. See. Maximum value is 360 minimum. Should probably be 50 because when it's 360 is essential. We'll take care of that because I'm now thinking do a modular card. 360 module. And whatever the remainder will be is going to be there. Sixty over for argument's sake, let's choose midnight. We'll do something vision. Let's say it's kind of 2 in the afternoon. It's 2 in the afternoon. They actually set this to 0. So we are not. Oh, run. The values 14 times 60. Okay, let's go by this. 14 times 60 is what exactly? 860 40. Tuned up enforcement. I think I just realized way more. Yeah, I really started on the wrong. Well, when it's noon, yeah, I think this is 90-degree off. That is the way I feel when it's noon. That I should have 180 degrees because for a 24-hour long day, if I'm right in the middle at noon, tendency is that should be sort of halfway through the cycle, which should be 180 degrees. Everything is off by 90 degrees. That is the problem. So whatever this is like say new alpha clock. So this is going to give you 720 minutes. You do this over a day. So this gives you half the values, half, and then multiply 360. This is 180, but that you want minus 9. Always has to be off. Let's try. I intentionally chose it's not a, okay, so this kind of made sense. It's like 4. I guess I'm still looking at this slider that I was thinking the slider would have other issue. So let's speed up the time. I think this is working. So caught up on looking at the slider. So let's speed this up 5 times. Could alternatively do for every time this kicks 10 times. Still doesn't make. This is still 0. When it's at 0, it's sunrise. You remember, I was always casting like the east. We were always seeing this along this axis, the right side of the tree side. So this is truly 0. This slider is actually showing value which is 0, but it's wrong in the sense that you don't want to get. So this time value 0. Okay, so why do we get 0 here? So hour is what exactly? So 15 something. Soon it's going to be 16 something. So 16 times 16, 60, and 60 over then 1,400. Is 60, 150. Actually calculate this. I would normally use debugging, but this is going to be so fast. Changing screens. Addition, of course. Minus 90. Why are we getting? Because if everything here is 0. Doesn't make. When we get this value, it's the proper value, the date. So we are getting the hour, which is 16. If this is 0, everything here is 0, this is 0, 0, 0. Of course, we are going to get. Why is this? Nope, it's 16. Okay. increasing. That's good news. Where exactly? Does it even make any difference? Just before noon, still 90. Targeting 960. Oh, this value is too big. 960 over a value of like billion here. It's essentially zero. So what was I trying? 60. Let's have it passed. Or so. That corresponds angle of 720. 1000 per 40 minutes. Half the day. Some useful information. That's how I realize off by fix this. Because European, say, the clocks show all zero, essentially zero. 6 hours later, 360 minutes, another 300, only another 300 will go by. Then it resets and makes more sense. The way we were looking at that horizontal slider, the values will go between 0 and 3. As soon as it hits 360, it's the same. So this way of going from top to bottom is fitting that horizontal slider look. These values are because there is still that by 90 degrees logic. Makes sense that between noon and midnight there's 100 difference. It's the opposite. It's not exactly 0 to 100 as the start and end is 72. And as I was saying earlier, 270 in one universe is essentially minus 90. Take a short break. Key, group, and we are back. Seemed like a very simple logic last night, and yet I just can't seem to figure it out this morning. I actually left something out last night because I thought this was going to be a slope creep, but maybe should actually focus on, because okay, let me first tell you what I found yesterday, why I dismissed it for the sake of keeping things simple. So here's the March dates. So March 11th. This is where we are. So sun rose 6:36 in the morning, and will set at 6:19 this evening. So this gives us close to 12 hours of daylight, which will be an important game feature for us. That's the goal for the next streams. How much daylight is used by the plants and such. But for now, we are just simulating the sun's place in our game, the rotation wheel. So as you can see, there is the degree calculation here. So it's 6:36. The sun is at 94 degrees. Now, when you look at the 90-degree here and what kind of timeline corresponds to that, it's right around 7:20 to 23. So this is what I was saying earlier, that we can't always assume 6 is 90 degrees and noon the sun is always at the highest. So like let's find the solar noon here. Say essentially noon, as far as our clocks show. Oh, I might have no. This is true. This whole AM PM business, but let me make sure I'm reading it. Yeah, this is true. This is the real noon. Because it's 11 a.m. in the morning. Then as soon as it hits 12, then you have 1 p.m., 2 a.m., 3 p.m. Then it's 11 p.m. when it turns midnight. They say it's actually 12 a.m. and then 1 a.m. Just fucked up, but it is what it is. So yeah, the real solar noon is basically half past 12. And as we approach the summer, you can see um, this value is 29 past 12. Gets closer and closer to 12 p.m. And we have to dismiss this daylight saving time. But essentially, these values will approach the civic noon. What most people consider noon is 12 o'clock. Let's actually move the calendar 1 month ahead. Let's go as and the so-called June 23rd. We have the most daylight. 21st. Somewhere. And only when we hit June 21st, we will have now the opposite effect. The minute values will go higher and higher. Because now we are having a shorter daylight. So I feel like there is something going on here with the angle values, time of the day. And if I could figure that out, I could actually incorporate that into. And another thing I'm noticing, which actually makes perfect sense, and this is what I was actually explaining here in the game. These are primitive values, but when you have the sunrise and the sunset values, the way they wrap, they should adapt to 360. Here we see that case. In the morning, when we have the 58 degrees, sunset is 302 degrees. So it doesn't make sense to add the hour and the minute values, but when you add the angle values, they should add up to 60. This is kind of double the value I'm using. Because for me, between sunrise and sunset, I'm covering 180 degrees. Here, the sun is actually covering a full cycle. They will always add up to 360, but the values will be and then there's some other level of control. It's 6 in the morning, May 8th, 65-degree angle. Then very close to 65-degree angle, we are 1:13 in the afternoon. So in the game, again, without the daylight saving time, this actually will be 12:13. So it's still 13 minutes more than just the assumed 6 hours. But why would you have a degree value very close to the sunrise? I think what these values are these values represent a whole different value. This might be the sun's angle, not according to our origin, how high in the sky, but maybe it's over the zenith. Let's see. I don't think these values will go. And so 122 January, and then it goes down. Yeah, these values are not the values that I'm trying to calculate. It's a whole different. I might be using different for the wrong name. I think what I'm sun's angle over horizon. Yeah, I think that's what that number, which will be important later, calculate sun's contribution to the plant growth. But that's not what we want, right? This is for Toronto. Size. Six 36, 36 sunrise, 6 data is correct. I might also need values like this to overcome that below the horizon and the light contribution, that like just before this dawn value, I may actually cut off the sun's contribution, take care of that light creeping error, so that it actually stays off until stays off after 1847 is dusk, and it keeps being dark. It's fine. Let's find some kind of angle. Corresponds to 4 or 6, right? And then there's this 42, 9. More so. Yeah. Yeah, I think my assumption so far is that east, and then I'm trying to change the elevation angle. So how elevated it is sky in the sky. And here it's represented as actually looking at this angle here. So the angle between zenith east is here, it's here, elevation angle. Yeah. So the angle between east and north is shown here as azimuth. Okay, let's feed in these. Does it want latitude, longitude? This guy. That's latitude. This is daytime. Daylight saving time. Zone is see if these values are matched. What if we do 1 here? 0, 0, minus 20. Does it? Yes. But then why are you asking the time zone? Just figure it out from the location here. And the longitude is wrong anyway. It's minus. Okay. So doesn't matter. Search. Say okay. This updates. Fine. Still not so sure of this. Okay. It's -5. Resign. 6:15. 6:36. Okay. Closest is this is some kind of angle here, which is off. This azimuth value though making sense now. Where was I seeing that? Google search? This value. Okay, this azimuth thing. So between east. Okay, it's just the table is about this graphic, the same side. It's as if this line is connecting all the way here. So it's this circular motion. So that's the azimuth angle. So when its azimuth angle is 0, it's north. Whatever the fuck that means. Yeah, say it's 0. It's marked as north. Okay, so say it's 0. So it's like 1:30 in the morning. It's 1 hour 30 minutes past midnight. It's practically zero. It's marked as north. Just doesn't make any sense. The elevation angle sounds like it's is what I need. Because in some parts of the world, depending on where you live, sun stays longer in the horizon. Doesn't go high, but it actually makes a very long traverse. So in that case, let's say I'm guessing based on this interpretation that it's covering a very wide azimuth angle. The elevation is not high. You know, where they say like you have like 6 months of winter, 6 months of summer, like the summers are really long. The sun stays very long in the sky, or disappears during winter. When the elevation is below horizon, that will be minus values, say, like this. But I bet if I actually feed in a very northern location, these elevation angles will be below zero for most of the day in the dead of winter. Let's just try. This is current position. So let's pick as north as humanly possible. Well, Hammerfest it is. Nope. Good. The shit we want to use. Time zone, again, I don't know. Why should I care? Let's figure it out. Execute. So March is not exactly, say, December. Good date. So minus, minus, minus. It approaches zero, but it never goes over zero. So my interpretation was correct. It is staying mostly below the horizon. So there's some daylight possibly, but it's mostly dark. So the elevation angle is important for our game. So this is how high the sun shows itself over the horizon. That's going to be needed at some point. Is that what we need though right now? Although it doesn't seem so, might be exactly what we need. Because in a similar scenario where the time is, say, not December, but June, for this northern place, then the elevation angle will always be above zero, but will never go below zero. As we approach zero values, we have a lot of values here around this minimum point, 4 point something. Let me run another calculation. Current position. Yep, just figured out where I live. close enough. Done. This kind of looks different than solar elevation for a year or a day. Ah, oh, that changes. Hmm. A copy of. Yep. So yep, right around this time, because we have proper day and night cycle, this part of the world, these values will minus during some hour and will be above zero some other hours. And then this is exactly how I was planning in after sunset, which is 18:15. It will go below this. So these values actually reflect but of course the true geographical calculation exactly where sun's angle is according to Earth's center and such. In game situation, these angles quite work out. So here's what I'm thinking. Say after dusk, we lower the values. First of all, where it shows zero here, it goes below zero. That is where our game, the rotation value hits 180 degrees. So we can always add 180 degrees to the values we see here. So it's or close enough that it actually shows 100. But then in the game we are trying to increase the 180 value up to 360 and then come back full cycle, so it actually resets at 0, so we can increase the values, come to 90 for noon. So in this numerical scenario, after dusk, in order to get to noon values, so we go below 0 more and more, we hit almost minus 50, and we start to increase the values again. But then these values are not exactly according to our game logic, these numbers should have been increasing. 59, 69, and then at some point reset. So Let's focus on the azimuth angle. That seems to be doing more of a 360 degrees cycle. That's that. And for this Hammerfest, 76 increasing, increasing, sits here. Seventy-six. So actually, azimuth angle seems to be fitting with our circular model better. The values may not be correct, double check, but it's cyclical compared to the, which always hovers around a certain value and then kind of goes between two extremities instead of cycling. If I could crack the code for Toronto, and then maybe I can figure out why it's say like the here's where the transition happened for Hammerfest. 15 sorry 18:15, 18:30. It's like 6 in the afternoon. Let's check the dates too. For today, go with that. By the way, there's still some confusion over this -5. Because this is in Sweden. I think they are 3 hours ahead. In 8 hours ahead, so it's GMT +3. So let's see if this is going to change. And it changed. Bucket. So for Toronto, they did execute again. 349, 318. So for Hammerfest, transition happens 2:30 in the morning. For Toronto, it happens a lot earlier. Let's pick somewhere the equator. Google Map skew. Let's pick somewhere along this axis so the time difference is 0. Here's the equator. This is Greenwich. +1. Okay. It's close. Close enough to 0. Time zone is do it. Whoa. A lot of values squeezed into this area, then sharp spikes here. So where's the this is why you should check extreme cases, because in this case we no longer have that going over 360 zone and then resetting to 0 logic, unless we actually count 214 to 157 as quick reset, which happens over the course of and so that means you even have even more drastic here. Minus G 5. So 7. Minus 50 is, so at this point angle between this point and horizon is 50. And here is as high as 43, almost 45. Okay, so this 43 here, so basically this graphic is giving us say for a person looking into the horizon, we'll see the sunrise, and the sun is currently making a 10-degree angle here. And at noon, which is not 12 o'clock, but it's 1228 where the sun is at its highest altitude. It's only making 43 degrees. And that angle is again calculated between this axis and this axis. It's like this 45-degree angle here. Whereas in our game, we would like to think of this value as directional light's rotation looking down. That's the whole confusion. Because this chart here corresponds to what I've been observing for Toronto. This value minus 49 or 50 at 0 hour here, and that it should be 43 degrees at solar noon. Yep. So at least all these websites are consistent. They are calculating all these values according to some equation, which doesn't make any sense in terms of our game object. So I have to find a way to match all this real life data to game specific values. I guess that's gonna have to happen after lunch. So, but this is going to be an important part of the game where sun's energy contributes to the growth of your chosen plants and where you play the game. Because the plan is to have the game in the game world, you could pick different cities. So whether you want to play in Toronto or maybe in a tropical area, your location should matter. So this is going to be an important factor. For the vertical slides we are working on for the game conference in May, I thought of getting rid of this real calculation, but it still proved to be difficult to do the proper daytime to rotation calculate the correspondence. So I'll have to decide if it's not too much work. Then maybe I'll work on mapping these values to the game object values, or I'll still go with a simplified but correct version. Maybe I'll stream one more time in the afternoon after I decide what I'm going to do. But for now, this is it. And I'm back. Change this formula because I tried to simplify things again. So I'm not going to go with the exact calculations for maybe a date because there's still so much to do. I have this tendency to make things perfect and then it's never done. Done is always better than perfect. So let's go with our original basic plan. We can actually do this. Then maybe at a future date we can say, well, it's not exactly at 6 in the morning, but 6:18. We are going to map the cells to the correct value. But for now, we don't even seem to be able to map the angle values to somewhat imaginary hour value. So I wrote down some numbers here. So when we do 360 degrees, we are spending 1,440 during a day. So, well, naturally, 180 degrees. What is the hours? That's good. 7 then 20 minutes, so that's all good. And we actually talked about the minus 90 offset or the 90. So say this is actually practically 1,440 minutes, which is, according to my calculations, it's 360. But because we have the 90-degree, so that's 270. This checks out. So for 360 minutes, according to this equation, going to be 90 degree minus 90. That's okay. 720 said it's 180 minus 90. When it's 270 degrees minus, so 800. So given the value of minutes, which is here, daytime, hour value times 60 minutes plus the minute value. This is the whole, given a number of minutes, we are trying to calculate. So I'm just going to reverse my equation here. This for 1 minute, essentially 360 over this value, which is correct, and whatever minutes have passed, minus 90. This should actually give us the real rotation. Now, I still saw some discrepancy, some unexpected values. As if we are still outputting minus 9. Don't quite. Still good. Actually going to cast its float because I think it's essentially, if we are getting minus 90 for rotation, this should print out 0. And it is. We know that this can't output some fraction, but it is actually. Since this is 0, this is really missing something. So yeah, Just do float. The breakpoint. Right before we print. I want to see the value. Something something 0. So just as long as I'm not going crazy that we are outputting some. I remember seeing decimal values here. It's not like output here is only displaying in. Okay, it's as if this is so basic. It's float from integer. Something. Variable is of, so the type is float. That's fine. When it's displaying, it gets rid of the decimals. Try the other way around. 140. Yes. It's 4 net. It's fine. 300. There should be some decimals. It's still showing like it's rounding it up. If I say 200, it should be 7 and 7. Why? So frustrating. Like, thank you. Just autocast it. Some. That's the type of output to really still 7. I still don't understand this. all this time, the angle calculation has been wrong because we just can't get decimals. I thought my math has been wrong. Pseudo float given precision at this point. Not even how precise, it's just plain wrong. Sir? Oh, there's a rookie mistake. But I'm specifically casting it to float. Yeah, but nevertheless, I should still see decimal 7. So the float doesn't. Yeah, 1/4 is 0, not point. Why isn't it? Yeah, well, integer divisions. Is one of the numbers floating point. So even though, okay, because it thinks it's actually dividing integers, and so if I do like f, of course that works in C sharp, float. Because I'm casting it to float, like yeah, imagine I'm getting integer values fine. I just want to get the result in float. Why can't I do? I guess you can always convert your integers to float, but then maybe. Oh boy. And assuming one of the numbers is float, that has to be enough. So if these values are integer, it shouldn't matter. So let's actually keep this one. Don't even need it. So this over rotation. Ta-da! That was stupid. Now if we feed this in, yep, So I see the sun's movement. So I think we may have spent 3 hours for it. But okay. And now everything actually looks a bit janky because the increments are 5. Rotation, tick count is, sorry, steps are 5. So it's actually doing its own automatic sort of, even if you go for an in-between value, it goes between steps that are 5 value different. That is the reason why. See it when we hit 270, the sun is actually right under Earth or the plane. And that was interesting. Okay, we'll actually play with the proper values here, the right track. Sun value 2 times. It's 90. I'm going to decouple this horizontal slider. Although that was useful, it was in the first prototypes. Changing the sun's angle through a horizontal slider, feeding this rotation values into the slider so it can control the sun's rotation seems redundant and counterproductive. Because now there's so many values, decimal values that you see, that we just can't possibly represent horizontal slider precise way. This is how we decide the step values, minimum maximum values. You know those, but then the step value will be increasingly difficult to make. So we have to because before we actually had this revolve, would start it and running this revolve function calculate the horizontal sliders value and would actually have a proper day night cycle, but we are not automating through rotation values. They're actually sun's proper move is controlled by the, so revolve is gonna go and we are no longer setting this, getting the rotation directly just like that. There will no longer be text. Still go. And as we know, no longer seems it's a twin we were changing. This might still be useful. maybe not. One of the mechanics we will have in this game is we are playing the whole year, every day and every minute of this person's life. Um, so you wouldn't want to necessarily watch plant grow every minute, every hour. So you will want to fast forward the game. So in that case, the minute values that are fed into this function will be changing rapidly, which will automatically change the rotation by itself. This is taking queen. I'm going to remove this for now. I'm going to always put it. Let's try. This looks much. So as we are approaching 6 in the afternoon, shadows are getting longer and longer. The dusk time, right around. And this is the problem I was beginning of previous stream. Normally, sun is below the horizon here. But because it's a directional, yeah, I haven't done much 3D work, so I'm guessing the directional light, according to the explanation, has infinite rays. Like the position never matters, but it's and when I created a plane, this ground sample start. We have this ground, the grid map. So this grid map size grid maps. A while ago, I some code build this grid. It's 100 by 100, so 50 in the minus 50 and plus 50 axis, also in the z axis. So that's actually 100 by essentially so the idea here is that sun yeah, we can really see this scene, directional light is facing somewhat upwards, but we can't really get this preview in. Well, it would have helped me things at least for me. But we know that it's actually facing up at some point. So when it's noon, it's facing downwards, minimum shadow, and then it's progressing this way, below this, and right after 6, below this plane. See, yeah, I think the game is actually reflecting, even if it's not showing the preview of the sun object, the fact that these trees are highlighted on makes me think that it's still calculated. Actually see it in this. I'll go to the sun and I'll do the opposite angle. Say instead of 90 degrees, say it's 70. Oh, I'm forgetting it's looking down. So it's almost noon, rising, 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 sometime around 11 o'clock. The game view, save. Okay. So now we get to see the right part of it's almost. Let's go and do a 45 degree. It's 6 o'clock in the morning, half noon. It's halfway, so it's like 9 in the 45 degree. So perfect. It's cast from this thing here will be direction. Similarly, it's not facing this way. Yes, as we less it's actually have to do. So it's before 6, like 3 in the morning. When it's upwards, that was midnight. So 6 is going to be here 3 in the morning. Okay, so we should not be seeing anything because it has to be below this. That is the problem. And this tree model doesn't have, well, it has the normal spacing. It doesn't have double faced, but I bet you actually had normals inside. You would actually have light cast there. Is anyway, I think I've already proven my this to myself. So this is the angle calculation is not precise. It's correct, but the implementation here, as far as the lighting controls go, it's still not satisfactory source. because I actually want to solely depend on game object. If there is no sun, there's other light source. Whole scene should be. Maybe it's not the best way to do things, but I don't know. It kind of made more sense instead of approximating things because I understand it's urban and we have some kind of light pollution city. Get that, but I want to create that artificial light intentionally rather than creating some ambient light. Because if I could figure out sun's proper light, I'll have to do artificial light in it. I don't want to turn all things, so could actually stay in a pitch black condition. Then maybe I can balance it. Right now, I want to do one thing right and then match if necessary. If we have this ground, just a wild, what this is. You look at this. This cinematic preview is already showing me that with the same conditions where the sun is passed from below, the fact that I'm actually seeing some light here, we haven't fixed anything. It's not about the scale. Could it be that this geometry is casting shadows? Turn this off because I'm already depending on sample level. This grid map. Huh. What if this off? This on? This on? Question number 1. Why are we seeing a blue space here? the fact that we see the real dirt color, the brown color that I real, when we turn up the ambient, it's all white, which is like sun is up and it's high. So this is what I want to black, no ambient color. The sun will do its thing, that's fine, problematic. But shouldn't I be seeing tint of here instead of blue color? So I'm going to replace this CSG mesh happen to here. Seem to rotate, and I think this is where I was trying some kind of wall logic to block the sun's recast. Let's keep that for the instance here. Mesh instance. Delete this ground. The plane. And the material will be transform. Okay, this is promising. The fact that I see pitch black is because there's no ambient light. Yes, so if I hold the color, this I'll get to see the same color. It's dirt. It's the color we like the dirt. Stand before it. Good. Now, this ground object is still letting the sun ray go through itself. Do we handle that? No change. This is about casting shadows. Anything should change. It's about the shadow it's casting in this direction. It's coming down below. Time to fill up my teacup and maybe I'll read some document. Figure this out. Intuition jobs. Slide. Just want to look at the answer is so simple. Math. Light will affect. Right now, it's affecting all layers. Quick test. Let's turn up the color. Brown to invert faces. That was in the PSG mesh. It actually hit this error. From this angle, we cannot see because the normals are facing down. So if we do this, so normally, now when we change ambient color, perfect. The reason why this is not pitch sun is facing 45-degree angle from like this trick. And if we change this direction of light to 90 degree up, I'm guessing this is seems lighter. I'm going to change the angle to 15 degrees, very shallow angle, like 10 degrees. Yeah, different. Which one? It's practically for going to look black. No matter what we do, though, still did not have any impact. This guy. Fact, 5 now. Kind of did some. Okay, because one was practically sunrise, 0, and then -degrees. So that's actually so positive values are actually below the horizon. So one is basically now it's 45 degrees this way. The fact that we don't actually see uh, anything highlighted on the side of the tree is problem. So what is actually happening? here is that the ground object, unlike before, its normals are facing below, downward, or whatever. It's in the with our axis. It's in yeah. So it's actually facing minus y, negative y value. So the fact that that's happening is perfect. It's after 6 p.m. You don't see any light. So we get to midnight. It's going to be cast right from below. Everything is by that. Get to 6 o'clock. You should see the first. We do actually have camera. Should do it away, so we actually have some light cam. Normally, what's coming here way, so we should actually have. And close to 6. You should see the first. The sun is going up around 9 p.m. 45 to still. You see shadow cam. But that is the problem now. The ground is no longer receiving shadow. In order to show the shadows, it should have facing camera drift. It doesn't have. Now the normals are facing downward, which is blocking the sun, but not receiving the. So we kind of want the best of both. Hmm. Shadow is on, or it was receiving shadows facing. What doesn't matter. We do double side. Let's change our view. Almost 6 in the morning. Still see shadow here because it doesn't matter. Side. To do with our existing problems. Kind of want double sided. I could turn this into cube. Very skinny, wide cube. That should then have normals on all faces. It will naturally block the. Will actually have shadows. I'll actually position this cube so the top of the cube is ground level. Cube mesh. Difference between cloud mesh. Same scale. Realism. Okay, so when I was dealing with the plane mesh, yeah, I don't remember choosing skeleton. Dirt was still dirt. Could still use a cube, but I'm just curious discovering stuff. Plane sounds like plane has more in it. Quad is just enough vertices to give you one big quad here. To get quad mesh, square mesh. Doesn't have a thickness. Plane is aligned on the x and y axis. Its default rotation billboarded. Plane mesh. This mesh doesn't provide subdivision. So, okay, I was guessing it right. The other one has more geometry. Size. But yeah. Oh, instead of scaling it up, this one. Realism. Some do. I think I give it in the here. And it's 50 by 100. The fact that it's showing it patient. Oh, oh, because it actually said it's aligned to. Okay, I know. So it said it's like billboarding. I think this technique is used to represent grass, things that always face the camera, no matter which way you look. Um, not going to be. But it also mentioned that the plane could have thick subdivision size. This determines flip faces on hard part. First, by knowing that I grew up. Okay, this is still facing upwards. It rotated and but let's try this. Flip faces. Okay, so we don't have to rotate stuff. promising. So when you talk about x and y, this x and y is basically a vector representing size. It doesn't exactly mean it's the x and y. This is axis independent. So yeah, the only question I have is, does width and depth still gonna flip the faces back to its normal, going to do 10? I'm guessing it's going to divide thing on this axis by 10. Whether it did that or not, I don't quite. I suppose you could actually, maybe if we apply the height map, going to do some displacement modifier, then it would actually need, and I guess doesn't have a thickness by default. Good. Okay. Number of subdivisions, that axis. The fact that this is showing y is the second set of value. It's not exactly represented. X corresponds to axis and y here, just the way a vector is represented. So going back to the 3D world, so now we can subdivision along this 5 subdivision z-axis, because ambient color is all black. Those subdivisions should be even kept, because this is what we want. Neither do we need cube. Cube with faces. Double checking that it's indeed working. It's ground. Now because it actually has 2 units y-axis. Means we have to move it 1 down in the y-axis, so it's flat with the grid. Translation is 1. I think now when we run our thing, now the shadows are cast properly. Good job. A bit painful, but it's working out. 9 morning, angle is 40. Shadows are getting shorter and shorter. Are lit. Shadow is going. So this is a primitive representation of course not always going to be one axis. Shadows will cast on a different angle than just the Z axis. Right now they're only cast on one axis. Because depending on where the player is playing this game, different city, angle will have to change. That calculation will have to be done. Right now, because sun is below horizon, see no light, and here we're going to introduce city lights. So now I can decide whether ambient light within the game engine should contribute to the overall lighting. The reason why I wanted to do kind of pitch black situation is because in the future, most likely after this game, Urban Farmer, if I tackle RPG, there's a dungeon situation that there should be no lights, cave or very deep to represent the real light coming from a torch. I wanted to have proper dark ambient. Somehow it feels right instead of approximating. Let's sit here and think achievement and what else I can do today. Another reason why I'm actually insisting on this true color instead of an ambient approximation lighting condition, because when I pick colors, let's say when I have this dirt color without the game running, right now this ground object has the dirt color. When I look at this dirt material, I remember choosing RGB value for this dirt. This could be actually grass, I don't care. It's green or brown. When there is ambient color in the scene, what I see in the game engine is the kind of like the post-calculated value, the visuals, never seem to have the same color that I picked in the inspector. Unless something has changed. Say something like this. Of course, now we have this grid view here, but you actually get to see this. Let's look at these two colors seem very close to each other, but what I noticed with more vivid colors, the discrepancy is bigger, but the problem gets worse when you have artificial, such as sun here. We do this 45, so you'll actually get to see my. I'm not going to save the scene. So this is with some ambient color, some kind of dirt color, which still seem like it's close enough, maybe acceptable, but introduce the artificial color, suddenly it's lighter. Although that makes sense because now there's the ambient color, ambient light source, and the directional light, sunlight. So of course both will be added, and this will get lighter. But then I no longer have visual fidelity between material color, like what I get to experience. See. So, in my opinion, this is not acceptable because say I'm working with an artist. This person is picking a very nice tone of green, and we do maybe Blender work. This person presents the work, and now I get to put it in game engine, which no longer looks like what I. So, um, is it the artist's fault, or my bad that I didn't communicate that whatever values this person was picking, that the colors should be altered in a certain value, certain way, so that when they are imported into the game engine, they're rendered properly. But that's always a catch-up game. When you go down that road, you always have to keep updating things. So this way, I'm hoping that by only depending on one source of truth, that I can actually have visual fidelity. I might be wrong. This is the first 3D game I'm developing. Because when you work with 2D assets, you know, don't you may still work with light in 2D, but since it's sprite colors, it's usually one to don't have worries like this. Back to black. Yesterday I was implementing this time passing mode. Our game will also have the player's cash value to work on the time pass. I could actually maybe a better way of improving this time passage instead of going into the currency domain is to create some basic interface where we do the stop the game, fast forward. It's like normal speed, fast speed, faster speed. That makes more sense. Some let's see. So we have a basic HUD here. And this sun will have to come out of the HUD because it no longer makes any sense. Before this sun scene had a slider for controlling the sun's rotation, but it's no longer needed. So we'll have a new scene in the HUD hierarchy. So time. Right now, time scene is we don't get to see anything. These labels are filled dynamic values. So we will introduce buttons. What buttons have pose, definitely. Speed 1. you could have at least 2 speed buttons. There are some things that are not yet decided from gameplay point. The player will see transition of seasons. So game will show every day, a year. It's a continuous gameplay. So naturally, during winter time, player may want to hit the speed button so that the months are passing quickly. Now we actually have the passage of implemented right now. Just gonna run it so we can see it. But imagine right now it's winter time, and I'm gonna hit the speed button. How fast should time pass? And another point, it doesn't always have to be winter time for the player to want to speed up the time. Sometimes the player will plant seed sometime in April and they want to just speed the game up for maybe 15 days, not necessarily for a chunk of 3 months or 4 months. So some decisions, let's say, how many real seconds should correspond to minutes in the game? As an extension to that, when you speed things up, how fast should the game timer go? Should there just be some kind of interface? Seems goofy, but say when I remember this in Oblivion, I think Skyrim too. Not sure if they did this in Fallout. I think it's the same. When you wanted to sleep, your character like you would pick number of hours for your character to sleep. There could be an interface like that. That you get to pick, say, 1 week, 2 weeks. That actually would come up with its own proper interface and overlay where you actually select an interval. That's an idea. And that might actually be a better option because, I mean, there's always this case that the player will accidentally hit the speed button either as a keyboard shortcut or clicking that icon, and everything is just moving so fast. Maybe they want to hit the normal speed button very close to the date, they want to slow the game down again. Maybe they are just not precise enough. But if an interface is asking for their precise date to sort of like wake up and slow down the game, that might prevent the whole frustration for the player. So I think there could just be a normal pause button and maybe speed the game icon button that actually opens the space. We could try that route. So I'm still thinking out loud. Let's see. And when we have that interface, Maybe I should fire up fireworks. Some kind of UI work. White can. Just could the font be any larger? Sometimes I think of three different things at the same time. I jump ahead, but let me give you some feedback by some like backgrounds to why I'm kind of trying this UI overlay for time passage. Is because right now my time function, my time class has this which adds two dates together. And in fact, we are actually using this time passage. We have the existing time. We add an arbitrary 2 minutes each time the clock ticks. Because this was my initial solution. If the game is in a speed mode, maybe we'll add 5 minutes at a time, maybe 15. But as I presented earlier, the player is not precise enough, these numbers will add up very quickly. So we already have it. So we could still use this if we bind this to an interface where the player is basically choosing, well, how many weeks do you want to progress the game? Maybe a month. We could just consider the month as 4 weeks to simplify things. Because in our game, we have, say, day 1 and day 2, but never the name of the month. So let's go back to the code. Say it's the first year and the last day of that year, you're on day 105. I believe my birthday was, I remember writing it down. A month. Anyway, I can't remember. It's 146. So when you say a month, we should probably add 28 days. There's a method here that actually normalizes these values, so you don't go into out of bounds zone. So when the days go over 366, it's automatically set to 1. Of course, I have to now do some more calculation here because we're arbitrarily adding some days more than 1. There's a chance you'll actually go anything above 366, which will actually push the day value to more than 1. But this is easy to fix. But this is the idea, using these two functions. Does it make sense to give the player a chance to advance the year? You know, it's about agency. Should the player always feel they have control over? Let's assume a scenario. The game will have soil conditions. If the soil quality gets so poor, the player may decide to plant alfalfa or some other nitrogen binding seed, and maybe they will not plant anything for a whole year. Come next year, they are expecting the soil quality to go up. They will want to play the game that way. So year might be just fine. Because otherwise, I mean, we are giving them a way to decide how many months they should advance the game. They could easily type 12 months too. So why not just give them a chance? Again, these numbers will work perfectly fine with this logic once I actually for those extreme out of bounds values. We already have something like this. Over 60 actually do modular calculation. So this will probably be an easier to, but that's for later. So this could easily be done with a slider. Let's look at the components. No, goodbye. Let's just do each slide. Each slide. Thinking if it actually going to take us to the tutorials. Oh, see, oh no, lazily copy and paste. Or wasn't there a numeric stepper range spin box? Numerical input text field. This guy. Because the minimum value is 0. So you could add like 10 days. Maximum number of days you could add could be 30. You look at so still right along. They are more or less the same. So it's to be here. Oh, it's you're even anyway. So if you go the H slider way, sliders can start here, sort of 0 month, 11 month, 12 month. It's fine. This is one way of doing it. The other way is this, here. Something. And of course, all this stuff will most likely sit interface like this. Beam running behind, going to be some kind of button here. Advanced time. There are the sliders. And maybe we could even show some kind of current date. Like game time will move to whatever values are put into the equations. Okay. Preview of the date, preview of the date you want to advance to. Approve done. Something button here. This is a skinny interface. Kind of has a nice balance because titles, fonts look okay. Simple button, but then there's for root date. And the date might be important to show the player. Because what if they are planning pick things up before a certain day? They don't quite know how many days or week have to speed the game up. By giving them a way to know where the game will pick up might actually be good. We actually need a wider interface to write a decent amount. It's going to this side for now. Text might be some kind of friendly text. Your farming adventure, farm mine, farming adventure, book. See, we don't go with March or day. They always go with the worst case large number 356 wide enough numbers. Off here. Let's assume they actually really like this game and they have been playing like there's no tomorrow, and they actually played 421 years game time. I may have to introduce our values. In that case, this sentence will actually, in retrospect, I usually like hybrid approaches. Whereas when I presented the idea of like getting rid of the ambient light in favor of using artificial light so that I could actually control their contribution properly, here is where we can compromise. Hybrid approach. Here's the reason why. It makes much more sense to give the player to a day, week. These are bulk values. But it doesn't make much sense to give them a way to move the hour or minute values. Maybe we will still keep the fast forward buttons, which will only speed up the minute changes, increases. And when that's not enough, they can always move the day or week by a certain amount. I think that makes sense. And it simplifies things here in the text to do that. Of course, it makes sense that when this interface is open, the game is so that this, for some reason, they hit this right before midnight. While they're fussing with the numbers here, it's the next day. Whatever day they are deciding here will just skew the number. That's that. Okay, so month. Again, there's no month concept in the game, but this should actually be here. We'll probably take care of that in the later in the game. Maybe it'll just be week build. This message should probably be on its separate. It's year, day, time. Let's stay true to our interface. Makes much more sense. This year, they for visual balance, we could something like this. We'll do the pretty design later. Button here. Button here for Oops. Thing like quickly check the screens. Message. Relevant. So what else can we do? So we talked about the passage of time. So we will have a pause button. I believe I already implemented some pause logic. Say morning time, I'm pressing space. Related to the passage of time, in going back to that time when I deleted the tween for the directional light. Because I remember a while ago, months ago, when I first did this sun cycle prototype, I had this vivid image in my mind that in some movies you get to see time passing really fast, and then there's the sun moving very fast, and you see the change of season, there's snow, and then summertime. I was hoping that as the game moves the time forward really fast, it would have similar effect. Would actually have the ground covered with snow, and maybe in summertime things start to look a bit dry, and then it's come back to you know bit of life with some rain. How can we accomplish that? This new mechanic of interface, because essentially the game will have to pause when we hit the approve button. There will no longer be the normal passage of time, but a very speedy change of a scenario number one. The player only wants to move the game one day forward. And if we choose an arbitrary number of intervals, 4 intervals, that's 6 hours per in 4 uh, different times, we move the hour values ahead. And then we can actually see the sun's angle. That's fine. We already taken care of that. Now, if the player chooses 1 week as the future date, how fast should things move so it doesn't take too long, but it takes long enough that we actually get that feeling of, oh, okay, cool, things are changing, dying, growing. Maybe more tea will help. Really, take short breaks and then I'll be back soon. Okay. So before the break, I was talking about passage of time. And I thought of extra thing might actually be cool in terms of effect if it's done properly. What if the intervals were changing, were moving the date forward, were dynamic? Say, still thinking. But if the player picks very long date in, say it's 6 months, they just want to get over the winter. So if there's a fixed amount of uh, time for between intervals, say every 1 second in time, fast forwards the game, say it, and if the person picks like even just picking like 15 days as a future date, waiting 15 seconds is a long time. Um, so it's as if there should be a maximum amount of time for fast forwarding, and for shorter amount of when the total when the date between a future date and current date is difference is short, this passage of time interval could also be short too. Say, I said maybe a second for a day. When you go over uh, 3 or 4 days for the passage of time, then maybe there should be some kind of could actually write that down in design document. Should pull up. But finding the right place in a long design document might prove it time consuming, so I'll just pull up the Trello. Just type it in the say description say player to the desired date should be interface. We have this interface. Close the game. Prove the whole new sentence. We should present one day of second. Real life. Real time. Real time. Teaching. Needless to say, should have really for moving time forward for more than 3-4 days. Prove to be boring. It is yet to be seen determined, but players find it fun. It a bit longer, several seconds. If the future date is months, or weeks away. Nevertheless, goal is to show off passage through reasons, patience in the gut. The intervals are too discrete. Then we might be looking at it's too frequent. It's too frequent. Then wait to write Maybe playtest. I think I should create a playtest. Playtesting of the things. Actually, you know what? Should not be creating this. This is redundant. Try this. Each of time should be tagged or it label. Have tags in. Nope. We do. We haven't created any. Purple for is for latest. Testing. This sounds like something. I don't think this actually should go in a vertical slice. I am using green for green lighting things for a vertical slice. This is definitely not a vertical slice item because I don't think I miscounted it. We have 9 weeks. 1, 2, 9 weeks minus 1 day for creating a vertical slice for DevGam. 9 weeks is a long time, but could also be a very short time. Don't keep up keep in check. So, although this fast forwarding time through an interface, through a dynamic interval value, that kind of thing seems cool. Focusing on that vertical slice is too much because we could just give the player, well, this is to impress the audience with the most common gaming of course, it shouldn't be too boring or too common, otherwise why are we doing it? But can't have the most basic things like well, here's a raised bed, click it, your seed, plant it, and then understand the basic gardening functions. Well, that doesn't happen. Fast forward the game, what are you going to look at? Still an empty yard. So the passage of time as far as the sun's rotation goes, what we have done today seems basic enough. It's necessary, it's good enough. A bit more polish is needed. Maybe I may dedicate a whole day to the whole latitude, longitude, so the sun's angle isn't always going right, like on the z-axis, but it's skewed. And then there was some this kind of like over the horizon. It's also making certain angle. I think this would be really cool because it's still going to be looking 90 degrees down, but when its placement on different axis is 3 degrees, then the shadows will also look cute, but it's not always in this direction. Um, right now we have day and night. That's fine. So maybe tomorrow I can. We also have basic camera angles, rotation, move is taken care of. We have basic zoom in, zoom out. There's some clipping going on here. It's, dirt should actually be going. We should be able to see the dirt. There's some clipping going on. But when we zoom out, we should see more of the yard. Yeah, I should some kind of basic yard layout and start clicking things to get some kind of information menu, basic UI thing. That's what I should do. So on that note, I think I'm going to sign off because I have a meetup to attend to. I'm organizing Godot Toronto. I'm also developing Urban Farmer in Godot, so it's practice for the group as well that I'm sometimes the group. So if you want to attend the event tonight, it's meetup.com, Toronto our page. So due to COVID, we are hanging out on Discord. So you could just come 7 Toronto time, have friendly chat with our members. Tomorrow there will be more of this development work. I think today was a big improvement in terms of this, sunlight. I'm hoping that we will actually have more of gameplay done to look more like a game other than a science project. There's been a lot of frustration with the angles and such, so we'll see. I'm signing off. Have a good night. See you later.